Well, good morning, everybody. I was doing a little bit of validation here and I came across a sequence that has a relatively uncommon thing going on with it. What is that thing? That thing is a group 1 intron. What is the group 1 intron, you might ask? I am not a geneticist. I am not great on a lot of the really nitty-gritty details of the genetics. So take this with a grain of salt. This is very much a layman's definition of what a group 1 intron is, but basically it is a chunk of self-splicing DNA that will insert itself into a sequence on occasion. So how did I know I had a group 1 intron, right? Like, this doesn't look like that long of a sequence, right? But when I flip over to the BLAST page, we have a bunch of really bad query cover. And so sometimes when you have really bad query cover like this, it means it's a chimeric sequence, right? So when you open the FASTQ up, you'll look and there's like one aberrant read in there that's like extra crazy long for some reason. But this is not this case, right? When I open this FASTQ, it actually aligns pretty well, right? Like, this is about as good as you're going to get. Like, there's a little noise in there, but it's not too bad. But when I search for our forward tag, so agat cata, look at how far in on the sequence your agat cata is. This is normally very close to the beginning of your ITS sequence. But right here, we're at position 560. We're in the 560s. There's a huge chunk in the beginning that is something else. So this is an ascomycetes sequence, and this is something that I would look at and see as a Collie group 1 intron. So then, knowing that, I can then go back in and kind of evaluate these sequences with the knowledge that what I'm looking at has a little bit of weirdness going on. There's two ways I could resolve this, right? I could cut out this group 1 intron and just blast it without the intron to make sure my query cover is good. Or what I could do, and I think it's what I'm going to do in this case, is I'm just going to put it into Eugene manually. And we're going to see, just do a little quick comparison to some of the other sequences to see like where they're falling and how well they just align in Eugene. So let me just double check my ambiguities. Don't think there are any, but okay, yeah. So we don't have any ambiguities here. So all I'm actually going to do is this is my initial sequence that was spit out by NG species ID. And then I'm just going to take one of these close ones, probably this one. Actually, we'll take this one. It's a fairly close Hymenoscyphus. And we're just going to open the accession number for that one on Mycomap, copy it, and paste that into Eugene. And then we'll just align it and kind of see how it's aligning in here. And look at that. So this right here is the group 1 intron. It aligns nicely after it, and it aligns pretty nicely before it. And there's just this nice little chunk in the middle that isn't aligning. So with this ascomycete, I'm going to leave this intron in here. I think it's good. It's good information to keep, right? Like, we know these happen with ascos sometimes. And then I'm just going to continue with my validation as usual. I'm likely going to be putting a temp code on this one just because it's over a percentage away from the next closest specimen sequences that we have here on Mycomap and the local blast. Actually, let me reorder that. And actually, yeah, if you look, there is this one, which aligns better. And I bet these are going to have that group 1 intron. So even though they're only about 96% similar, yeah. So see, this group has the group 1 intron. So it's interesting, right? So yeah, if you happen to come across a sequence like this that isn't like aligning right and the agate cata seems like it's in a weird spot, like don't freak out. It's okay. It's just a group 1 intron that snuck his way in there. Just validate it like you normally would. And probably mention in the uh, INAT observation that, you know, you do have that intron in there. That way, if anybody looking at it wonders why is this sequence so long, um, they'll know you checked it and it's not chimeric. It's actually like real. Hopefully that was helpful. Have a nice day. Bye bye.